Hi everybody. So at this point you just investigated various characteristics that might contribute to an epidemic level of an infection in a disease. So you were looking at the 2-day disease again, but in reality, epidemiologists have studied herd immunity in populations and determined what the level of immunization needed to be in order to be able to protect the remainder of the population. So I want you to take a look here. Look at these characteristics that you just tested about the 2-day disease and think about the impact it had on the 2-day disease. Now, these are the characteristics for smallpox, polio, and measles. Smallpox has a high virulence. There is a long duration of infection, and the rate of transmission is actually pretty high at 2.5. So what do you suppose would be the immunization level for herd immunity that we would need in order to be able to eradicate or protect people against smallpox? Polio has low virulence, 18 days of the duration of the infection, and has an average rate of transmission. Whereas measles also has a low virulence rate, only has a duration of 8 days, but has a really high rate of transmission. So what do you think that's going to do for the immunization level? What percentage of the population do you think we'd need for smallpox? It's 76%. Interesting. Was that higher or was that lower than what you were thinking? Polio is 86%. And then measles is 90%. My question to you is, does any one of these characteristics place a higher value or affect the rate of disease more than the others? It's curious to me because epidemiologists and people that work in the health industry and with the World Health Organization have investigated this concept and also taken a look at what actually happened as there were worldwide efforts to eradicate smallpox. So what you need to know is that smallpox was eradicated in 1977. The last active case was, I believe, in 1973, and we haven't seen any cases since 1977. I think my dates are correct on that. So what happened was the World Health Organization and the United Nations worked together to develop an eradication effort against smallpox. They basically went into third world countries and attempted to have vaccination clinics in the towns and communities. And so people would come and then get their smallpox vaccination. And it was as a result of that effort that we were able to produce herd immunity. And now that's why we haven't seen any live cases. So let's check this out. Bangladesh and Niger are two very, very different countries. You can see that Bangladesh in 1973 had 72 million people in it. There were 80% of the people that were vaccinated. And we just said on the previous slide that in order to prevent smallpox, we need 76%. So those vaccination efforts that they did were phenomenal. Now, the question is, they still had 33,000 cases of smallpox. That's 0.23 cases per square kilometer. That's interesting. Niger in 1969 had 3.9 million people. They vaccinated 79%, still above the number that we would expect to have to vaccinate. They only had 25 cases. And so their cases of smallpox per square kilometer is 0.00002. Now, the question in your lab is, according to the data for Niger and Bangladesh, how accurate is the simulation for smallpox? Was it accurate or not? Was 76% an accurate number that we would need to get vaccinated in order to protect those people in Bangladesh and Niger? And then, if not, what factor actually caused all those cases? The information is here on the slide. You just have to make the connection. Have a great day.